code, how you want to what you want to do. And having these decoupled in this way, the player can die and the health bar can do its own thing. Right, so with destroy game object, you could that would be a way to remove the health bar and or the player. Another cool trick that you can do, which maybe ties into what we're going to talk about today, is you can make the health bar lag behind your actual health. So you lose 10 health, and then your health bar does something like, okay, here's 10 the health that you currently have, and now there is a blinking line where it detracts slowly. I think you see that a lot in games like League of Legends, where it just gives you great feedback on, alright, this is how much health you just lost. And by decoupling those two values, that on the health bar itself and that the player's actual health, you can start doing that kind of thing. And that would be really hard if you just do that in the player class itself or something. Alright, that was about last time, so I hope that helps you fix that problem or helps you use the Unity event for dependency inversion. And then now I am going to this week's workshop. Alright, these can go. Oh, hang on. Will the health bar code be available on Canvas? This was code by one of your students, so if they want to make it available, sure. Okay, this is the last oof because I just closed the project, Chuck. No problem. I think the point is, I think we gave you the tools to create this kind of health bar with the documentation that we give. If it's the gradient that you want to copy, ask your colleagues. Maybe people want to share on Discord in code. Share what you've made. But of course, from an educational point of view, we want you to be able to create this by yourself. Okay, next subject, the endless road. This is an endless runner, Subway Surfers, I think, or is it not the real one? I don't know. I just googled it. Okay, I'm going to move my face again. Hang on. Smaller. There we go. I'm not sure if I'm squashed a bit now. Wait. Reset. There we go. For this workshop, we want you to give you some more tools when you're making your own game. And to do that, there's another pattern that we should discuss, which is the prototype pattern and prefabs, because they're useful in many situations. And this workshop will help you become familiar with that pattern. So we want to talk about prefabs. We want to talk about using prefabs for position and rotation. Pivot points are important. We already discussed those, so but just revisit that shortly. And the coroutines and yield pattern, and that's a bit of a weird one and very Unity specific. So if you are already familiar with software, this might still be a new thing. The smooth lerp, I'm not sure that's still in the workshop. That might be a mistake, but we'll see if we run into it. And the prototype pattern. Okay, I see that the health bar project will become available. Doesn't need to be on Canvas. It can also be on the Discord, and just throw it in the group channel. The assignment for today is an endless road, and there's like a couple. Use a factory and a prefab and a coroutine. Now I will show you what I just made in before the stream to show you the point. So I have a road factory, and this road factory is going to spawn blocks, and it's going to keep spawning them forever because I didn't do anything. This is just a very short bit of code, and we're going to get into what it is in a minute. So, yeah, why I already said, we think this is just general knowledge that you really need to know for your own game. The subjects, again, coroutines. Let's talk about coroutines. Coroutines are a bit weird. Yes, this works in 2D as well. It's the same principle. There's really, yeah, there's not much difference. Coroutine can be called in Unity through the start coroutine method, which is on your mono behavior. So your mono behavior can start a coroutine, and the coroutine looks like a function that returns IEnumerator. Ha! Quarantines. Very good. Start quarantine. Then, what they can do, which normal code can't, is the yield. So I can tell my code to stop, wait for a couple seconds, and then continue. Or a single frame, or yeah, whatever I want. Also, if I want to wait for next frame, or wait for a condition to be true. So, Shark, this is copyrighted material that you put in my slides. the guard walking on the top left is that's fine. It's from it's something I made for Harold, where he uses his nav mesh animation stuff to follow a path. That also uses coroutines, I think. Initializing game objects when you have to like do something that could take a couple frames, then you might put in a wait till everything's finished, and then your coroutine continues and does something. They're also great for animation. That's where the lerp comes in, that was mentioned. So we have a ball that changes color. You can, if you're familiar with the lerp function, it takes two values and then something between 0 and 1, so a percentage, and then it takes the midpoint between those two values. So if you have begin color and end color, which is black and white, and you have the timer here 0.5, then you will get gray, because that's the halfway point between black and white. You can also do it with two positions. So if you have position 1 and position 2, and then you take the lerp function and 0.5, then you will end up exactly halfway. If you do that like every frame, then what you get is an animation. So today we'll be spawning tiles with them for something like an endless runner. If you think that's too simple, which you're welcome to think, then we encourage you to try to create a maze instead, or like here, the road can go in two directions. So that brings an extra layer of complexity. So you don't have one exit per tile, but you have multiple exits per tile. Yield is you put in a method. Okay, I'll let's see, where is it? Here. So it is it's not in a regular method, but in a coroutine only. And the coroutine, what it does is, let me see if I can pull up on the other screen the manual with the execution order of events. So what it does is, here we go. Unity waits or checks every frame in the game logic, and here you see the coroutines. That means they just get updated every frame, right after update and before a late update. So you can actually see exactly when that will happen. Okay, I'll just put that away. It doesn't really. It's not. It's good to know that this will just end up on the single thread that your code runs on currently in Unity. It doesn't do any threadings. It will always update in the order that I just showed. So before the update. So this is all. There's no magic going on. It's all you can follow when this will happen, when it will update, and yeah, reason about that for your code. Another trick not mentioned here is you can, if you start a coroutine from a coroutine, it will wait until the nested coroutine is finished. So you can stack these on one underneath the other. Alright. Let's see. Yeah, I'm going through this first. Spawning stuff. So when you want to create a new object, spawn a new object, then you need a few tools. One is the instantiate function that is on every model behavior or game object. Prefabs are very useful for this, and I'll get into them in a second. And the prototype programming pattern. The prototype programming pattern. You can find the link for a much more extensive discussion of it. But the idea is quite simple. Instead of just writing down in code everything about the object that you want to create, you just create the object first in the editor, you tweak it, you put in all the values that you want, and you call that a prototype, and then when you need it in your game, you copy that prototype and you basically make it visible. Unity does that for you, and when you're using a prefab, you just say, I want a copy of this prefab in my world, and it will spawn it. In code terms, the object that instantiates this prototype is called a factory. So, this is what I just meant when I said you can do it through code or through instantiate. I think you'll agree the second version is easier to do than having everything, configuring everything from code. So they do the same thing, but in one term I've just created it in Unity, and the other is writing it all out. So one more thing about that: if you have some configuration that you need from your factory, so your factory knows certain stuff, maybe some manager that keeps track of the objects that have been spawned, maybe something else, position that needs to be, I don't know, then you can tell the object that you're instantiating, so not the prototype but the copy of the prototype, you can give that some code or some information. You do that by instantiating not the game object, which is what I did in the previous slide, but a script that you put on the prefab. So in this case, I have a script, a mono behavior on my prefab. It's called character, and when I instantiate it, I call instantiate, or when I call the copy function, instantiate function, I call instantiate on the prototype, which will copy the entire prefab, the entire game object. It won't only copy my character script. It will copy everything, and then I can immediately call my initialize function on it. In this case, I am giving my initialize function the factory, the code from which I'm calling this. So that's a trick for giving information from your factory to your spawned, your copied prefab. So I've put the execution order of events for this particular sequence. Awaken on enable will be called first on character because that's how they initialize, and then our initialize code is called. And finally start will be called. So we can do any initialization from externally before start is called and before update is called. Alright, here a quick recommendation about pivot points. You can use a child object in your hierarchy to set up your mesh and set up the position where your object will spawn. So I can just go back to that Unity project quickly, and if we look at my prefab, my block prefab, here it is. I can also open it here from the project view. That is the mesh. If you create a new cube, you will see it actually has the pivot point in the center. So that's the pivot point. But when we look at my own block here, we see that the pivot point is on one edge in the middle. And the reason for that is because of the way I set up the prefab. I have the mesh, which is the cube. The cube is just a great cube, which has its own pivot point. But I made it a child object of my block. And by moving those relative to each other, I've set the pivot point of the entire thing to one edge of the block. And I have put a next add, which is another transform, just empty transform at the other end of the block, and that will become clear why soon. So, back to the character class that I mentioned, which I don't actually have with me, so imagine it in your head. My prefab, a good way to use prefabs, which I have come to find out over time, is to have a single script at the root of the prefab, at the top of the prefab. In this case, it would be block, a script here, that you can talk to from the outside. So when you're instantiating it, or when you are, I don't know, have another script that has to communicate with it, you have that script to talk to. That means that if I'm working together with you on a project, and I ask you to create a prefab that does thing A, thing B, and thing C, you can go and create thing A and B and C and do that within your prefab, and anything that you need from me, any configuration or whatever, you can put on that root script. And when I get your prefab, I will see, oh wait, this is, on this root script, that is where I have to fill in any details, information, maybe how fast the character should move, or I don't know, anything that would be necessary to configure. If you are familiar with interfaces, that's a nice analogy from coding. You have the methods or the information that you need from the outside is as the hole in the box for interacting.